In this lesson, we're going to look at what are called special segments in circles and the lengths of those. So the first thing you want to do is in your circle book make these 3 circles with these different numbers on, and as I go I'm going to put some color into them. But the first example is this one, and I'm going to look at the relationship between the lengths of these pieces. And what you have to realize is we have 2 chords that are intersecting in the circle, and we're looking at the lengths of kind of each part of the 2 chords and what kind of relationship is there. The way I like to look at it is I like to look at the lengths on each chord. So like for example, the 3 and the 4, how will these 2 numbers relate to the 2 and the 6? And based off just one example, it's kind of hard to tell what that actual relationship is. So I'm just going to give it to you, and the way I like to think of it is if you take the 2 pieces on the one chord, multiply them together, for example the 4 and the 3, and you take the 2 pieces on the other chord, multiply them together, the 2 and the 6, it's always going to equal. So for my one example, it's obviously working, and if I went to a bunch of other examples, you'd see the same thing happening. Now on my next one, I would suggest you color coordinate it the same way, and that's going to help you see the relationship. So if I come back to this last one, I'm kind of trying to give things away here. I took the red and I multiplied it by the blue, and then I took the purple and the green and I multiplied them together, and then I knew those things were equal. Same thing's going to happen here. So what you have to look at in this one is if you take the length of the red, which is going to be 8 because you have the 3 and the 5. So if I take 8, multiply it by the blue, which is 5, and then I take the green, which is 10, and multiply it by the 4, it's going to be equal. And that will always work. So the way to think of this is you got to kind of think of it as that whole secant segment times just the outside part. So you may want to put here whole secant times the outside, and that's going to equal, well, it's the whole other secant times the outside part of that one. So the whole times the outside. And then in my last one, same thing's going to go on. I think these 2 are very similar because you can look at whole secant times the outside. So in this case we'd have 12 times 3, and that's going to equal the whole tangent. Well, the whole tangent's only 6, and then multiply it by the outside part of the tangent, which is also 6. You're going to get the same number. 12 times 3 is 36, 6 times 6 is 36, and you have it. And that's going to be everything to put in your circle book for the special segments and circles.